This is a practice test on our material on Chapter 6, although it is our 5th test. So again, we'll use that same protocol, hoping you will write something down, and then I'll go over the strategy of solving it. So here they're asking us to factor. So as we go into this here, we want to develop a protocol, a method of operation to solve it. So we have two terms, and we want to see what we can factor out of each term, the greatest common factor, and we know there's going to be a negative sign between the two. So we look at the number, and it looks quite obvious that we can take a 10 out of both of these. Then we look at the letter V, and the largest factor we can take out of each one is a 4. So V to the 4th. And then we have an X, and the largest factor of X we can take out of each one looks like X to the 2nd. And then this term has a Y in it, but there's no common Y. So this is what we can take out of both. So after we do that, here we end up with 10 goes into 30 3 times. We took out the V, and there's just an X left here for that first part. Now, we're taking out a 10, in a sense, so we could put a 1 there, but we don't usually do that. And then for the V's, we took out V to the 4th, so V to the 3rd is left there. We took out X to the 2nd, so the X's are all gone, and what's left is Y to the 8th. And that is the factoring of number 1. Now, for the greatest common factor, as we look at this, we have 25 and a 20. So what do you think we could take out of either of these? And if you said a 5, that is correct. And we have B to the 1st and B to the 2nd. So what factor or what power of B can we take out of each? And if you said B to the 1st, that is correct. Now, here we want to write all the factors of 14. So I maybe suggested you do the factoring tree. And let's see what we get here. Well, we can take a 1 out of there, and that would be a 14 still. We can take a 2 out of there, and that would be a 7 left. So we could take a, out of 14, we can take a 7 and get 2. And I think that's about it. So write all the factors. So we can take a 1 out. We can take a 2 out. We can take a 7 out. And we can take a 14 out. These are the factors of 14. All right, let's raise it up a little. Now, for factoring a trinomial, and notice here our A term, standard form, by the way, is a x squared plus bx plus c. So we're looking at our A term here, and there are no common factors. So we suggested you put 2 parentheses, and then undo the FOIL that made this, perhaps. And I think our first term we can agree is going to be 5y times y. So we could put the y here and the 5y there, but this is good too. Now our middle term is negative. So the factors of 18 are 18 and 1. That doesn't look like it's going to fly. Now other factors of 18, and I'm looking for something around 30, would be 6 and 3. That would give us an 18, but does it add up to a negative 33? Well, in order to get a positive 18, both of these have to be negative. And then when we do our outers, we get a negative 30y, inners a negative 3y, adds up, so this is a good one. All right, for number 5, again, there are no common factors. So we put two sets of parentheses, and I like it that they left me room that I can do it underneath. Again, this is prime, so it's 5x and x. Now, here this is negative, so this indicates one of these will be negative, one will be positive, and it's not going to be a 9 and a 1. And a 9 and a 1 there doesn't give me a 12. So I'm going to try a 3 and a 3. And I think this will work because now I see my outers are 15. My inners are 3 and the difference is 12. So that'll work. So I need a positive 15 and a negative 3x. And this checks. And when I say checks, I'm foiling it to see that it gives me this. All right, number 6. There are no common factors. And again, I like that they're a prime here, so we don't have a lot of choices. 3x and x. But again, this is negative now, and this is negative, so we're going to try different things here. I can go to, I know it's not going to be a 6 and a 1, because if this is 6, this is 18, that's way too big. So I think I see it here, a 3 and a 2. And my outers will be a 9, and my inners will be a 2, and that difference is 7. Excellent. So this would have to be a negative, and this would be a positive. And if I FOIL it, I get this. So this checks also. So as we inspect this, it's two terms, a negative. This is a perfect square, and this is a perfect square. And you recall we said that a squared minus b squared, that is the difference of perfect squares, factors into its conjugates. So what are the conjugates of this? Well, it's going to be 7w and 7w, and then 8 and 8, and one is a plus and one is a minus. And you could FOIL that to check it, and this checks. Now, as we look at 8, this is also the difference of perfect squares. So this will factor into its conjugates also. And again, you check by FOIL. So this is 2w, 3u, not 9u. Got carried away there. And one is plus, and one is minus. Now you could put the plus here and the minus there. Doesn't make any difference. Now as we look at this one, I'll write it up here so you can see it big here. 27 w squared minus 75 w to the fourth. Again, the rule for factoring is always take out the greatest common factor if there is one. And you'll notice 3 will go into there, and 3 will go into there. And we could take a w2 out of each one. So 3w squared leaves me with 9 minus 25 w squared, like so. Now, you've factored out, but it's not completely factored yet because this can still be factored here. These are the difference of perfect squares, so this will factor into their conjugates. 3 minus 5w, 3 plus 5w. And again, I could have put the plus there and the minus there. Okay, we'll raise it up to do the next few. Now, a lot of work that we did in factoring was so that we could solve these quadratic equations. And if you recall, the formula was, put it in standard form, 9v squared, which is this 9v. Now I'm going to transpose this 30 over, so it becomes a negative 30v, and transpose this over, so it becomes a positive 25. And then now what's left on this side is 0, so I will equal this to 0. So this is now standard form of the quadratic equation, where all the terms are on this side equal to 0. And now we want to factor that. There are no common factors. And I can see this is a perfect square trinomial. So 3v, 3v, 5 and 5, and they're both going to be negative like so. So if I FOIL this, or another way to write that, of course, would have been 3v minus 5, the quantity squared. Now, according to our protocol, we equate each of these factors to 0. This factor is 0, this factor is 0. And they're both the same, so 3v minus 5 equals 0. I'm going to transpose the 5 as a positive 5, and then divide by 3. Now, when the answers are the same, you don't have to write them twice. So this is the answer to number 10. I will leave that up. Now, here we have a right triangle. I'm probably going to need that room here, so I will erase that part here. We'll do the triangle again here. We're using the Pythagorean theorem, where this is side A, this is side B, this is side C, and the side opposite the right angle is the hypotenuse. Well, here they're saying the hypotenuse is 9. No, 9 inches longer than the longer leg. Alright, so we'll have to define this. Let me get back here in a minute. Okay, I should have read this a little more closely. Now I have it down. And what we're saying is, there is a long leg, which we'll call x. Now, the shorter leg is 9 inches shorter than the longer leg. So there's x. This is a short leg, x minus 9. And the hypotenuse is 9 inches longer than the longer leg, so it would be x plus 9. Now you may recall the Pythagorean theorem is a squared plus b squared equals c squared. So we're going to have x minus 9, which is our a, which we're going to square, plus b squared, which is just x squared, equals c squared, which is x plus 9. squared. Now what I'm going to do is do that, and I get x squared minus 18x, using that special technique, plus 81 plus x squared equals x squared. Multiply these and double it, plus 18x plus 81. All right, I'm going to work on this a little and I'll get back to you. So that it doesn't get too complicated, I see here I have an x squared and an x squared and an x squared on this side. So I'm going to subtract one of these x squares. And then now I'm left with this x squared. Now I'm going to transpose this positive 18x to this side as a negative 18x. So I have a negative 18x and another negative 18x give me a negative 36x. And then I'm going to subtract an 81 from this side and an 81 from this side. So these just cancel each other out. So I'm left then with, once I brought that over, this equals 0. Now I'm going to factor out an x, and I get x minus 36 equals 0. Now I equate each of the factors to 0. This equals 0, and this equals 0. Well, the lengths have to be more than 0, so we're just going to eliminate that one. And here we get x equals 36. So the length of the longer leg is 36. And if we subtract 9 from 36, we get the shorter leg is 27. And if we add 9 to the longer leg, or the hypotenuse, I should say, we get 45. Okay. So again, this one problem involved lots of steps. So when you get something like this, be sure you're showing your work that if you don't get it right, you can get partial credit because, I want to give credit for the work. Okay, let's pause and raise it up. Here we have an application, so maybe a figure might be helpful. I'm not too sure. I'll start to read it. So the area of this rectangle is 50 feet squared, and the length of the rectangle is 5 feet less than 3 times the width. So this will be the width, and the length is going to be 3 times the width less 5. So I think this is good here. So the length is 5 feet less than 3 times the width, so 3 times the width minus 5, this is the width. So we're using the formula area equals length times width. So we're going to stick with our w's here. So width times length equals 50. So again, this is what I need here as part of your blue sheet. Again, you're numbering your blue sheet if I don't already have them numbered. Now we're going to multiply this. We get 3w squared minus 5w. Going to transpose that over. I get 50, negative 50, equals 0. It's now in standard form. So no common factors, so I have to factor it here. So this is going to be 3w there. I want to put a 3w there. I could have put a w, but I like it this way. Now, we're looking for factors of 50 such that we can get this difference here. So, I put a 5 there and a 15 there. I'm sorry, a 10 there. So I'm doing this just like you would. I'm using pencil so I can erase. Because I see the outers are 15, the inners are 10, and the difference is 5. So this has to be the, I need a negative in the middle there. So this is the negative. It looks like my mouse froze, and this is a positive. Okay. And I'm just checking that. That's negative 15, positive 10, negative 5. Yes, that works. Now I equate each of these to 0, and this is going to become W equals a negative 10 over 3 that I'm going to reject because I can't have a length that's negative. And here the width is 5. Just transpose that. So here if my width is 5, and 15 minus 5 is 10, and 10 times 5 is 50, that checks out. Okay. Now we had a rather challenging Pythagorean theorem. This one's a little easier. Here it's going to be x squared plus 8 squared equals 12 squared. So here we get x squared, and I'm going to subtract this term from this side and subtract it from this side, and I'll just put that in my calculator and see what I get here. And that's an 8. So this is 144 minus 64 is 80. And then I take the square root of this side and get x, and take the square root of this side and put that in your calculator, round it to the nearest hundredth, and I get 8.94. And that's my answer. Okay, let's raise it up a little bit. Now in this next one, we're going to make a rectangle again. The area is 66, and the length is 1 foot more than twice the width. So this is our width, so twice the width plus 1. And we do this the same way. So W times 2W plus 1 equals 66. So this is 2W squared plus W minus 66 equals 0. Okay, we have to factor that. 2 sets of parentheses and 2W. W. And now we're looking for factors of 66 that will give us a difference of 1, a plus 1. Okay, I'm going to have to work on that a little bit. So, just like a student here, I had to do some guessing and checking. Then I saw a 6 here and an 11. So my outers would be 12, my inners 11, and the difference is 1. and this has to be a plus, and this has to be a minus. So here I get W. Again, I equate now each of these to 0. Transpose that, becomes 11 halves. And this is a -6 that we reject as an extraneous root because you can't have a length that's negative. So our width is, let's see, we can put it in fraction form, decimal fraction, 5.5. And our length, then, is 11. Let's see now. Plus, this is 11 plus 1 is 12. And those are the answers. Okay, let's clear this up. And we're looking for another right triangle. Again, we're trying to find the hypotenuse here. So this will be 20 squared plus 21 squared will equal x squared. So I'm going to square this and square this, add it together, and take the square root of that, which is what x will be. So I'll let you watch me do it. Well, you can't see me, can you? So I get 20 squared in my calculator plus 21 squared. Hit enter, and that's 840. Take the square root of that. And I go second function square root of second function answer. And it comes out a nice even 29. Ah, that's nice. I didn't have to round off or anything. Okay, let's pause and move it up. Students often get confused with something like this because they want to multiply, but it's already a factor times a factor equals 0. So we just have to equate each of these factors to 0. So this first one will be 2u minus 9 equals 0, or a negative u plus 8, in a sense, equals 0. And this is a u here. I didn't make that u very well. Looks like a 4. There we go. So this one's easy. You transpose the 9. On this side it becomes a positive 9 divided by 2. There's one answer. Now here we're going to, let's just transpose the u here. So this will become a positive u equals 8. All right, that was a shortcut way here. And those are my answers. Okay, jumping to number 17, we did a little bit of this. I have to put it in standard form. W squared minus 11w equals 0. We're factoring out the w. W minus 11 equals 0. Equate each factor to 0. So here's one answer, and here's the other answer. And that is correct. Now, if this is 0 and this is 0, it's true. If this is 11 squared, which is 121, then 11 times 11 is 121. So these are both answers. Now, number 18 is in standard form. So if we just factor it, and I don't know if you can see this, but this is a perfect square trinomial. or x plus 1 squared, quantity squared. So both answers are going to be the same. Equate each of them to 0, so x equals -1 there. And here's just another problem to do. We'll do it up here, another rectangle. The area is 65. And the length is 3 less than double the width. So there's the width. Double the width less 3. And we put in our formula, W times 2W minus 3 equals 65. Transpose that. Again, there are no common factors. So this is 2W and this is W. Now, for 65, we need a difference of 3. I'm brainstorming here. I don't know if this is going to work. 10 times 13? No, that's not going to work. So I'm going to pause and work on it like you would have to do. Well, I had the right idea. I thought of a 5 and a 13 here, sort of. So there's a 10, and there's a 13, the difference is 3. So what will my signs be? I need a -13, so negative 3, I should say, and this is going to be a positive, and that checks out. So when I equate each of these to 0, this is going to be 2W equals 13, W equals 13 halves, which in its decimal form is 6.5. So our width here is 6.5. And double that is 13 minus 3. This is going to be 10. And 10 times 6.5, this checks out. Okay, and then this one is just a W equals -5 that we reject. Okay, one more to go. All right, here we have the Pythagorean theorem together, and they're giving us a nice picture. So there's the building, and this distance is 34, which is the long side. The hypotenuse is 35. So, again, we don't know what the short leg is, and that's what we want to find out. So this is going to be x squared plus 34 squared equals 35 squared. Got carried away with my squared sign there. So in solving this, this will be x squared equals 35 squared minus 34 squared, and x will be the square root of that difference here. As I put that in my calculator, you can do it in yours. So 35 squared minus 34 squared is 69 here. And when I ask for the square root of that, I round it to the nearest tenth. It's 8.3 meters. Okay, good job. And they're all running over 30 minutes, but hopefully, again, a review as you prepare for your last chapter test, which is this one, and then your final exam.